Welcome to the Welding Codex. This is a podcast for those who want to learn more about the technical side of welding. We're going to talk about philosophy of welding, welding codes, welding defects, and topics like that. I am a welding engineer. My name is Garry A Pace. The other two hosts of the program are Peter Kinney and Joel Christy. Both are Ohio State welding engineers. Depending on who I can get a hold of and when, and have some conversations with those two individuals on various welding subjects. We are not going to be talking about how to weld open root pipe or how to hobby weld in your garage or the best way to weld up a frame on an old Chevy pickup. Not our game. We're going to go into full welding code geek mode and talk about some of the nuances of welding codes. AWS D1.1, ASME Section 9. We're going to talk metallurgy, all kinds of crazy things like that. All right. Hello. This is a podcast I put together. Maybe you guys have watched my YouTube videos in the past. My name's Garry Pace. I'm a welding engineer. I'm here with former co-worker of mine, Joel Christy. He's a welding engineer I worked with. Joel, you got anything to say? Any introduction? Anything pertinent that you'd like the world to know about you and your expertise in welding?
I've been a welding engineer now for a little over 10 years. Worked for a multitude of different companies crossing various sectors of business, aerospace, subsea oil and gas, topside oil and gas, and construction. So it's been around the block a couple of times and dealt with many, many different codes.
So today's topic is just weld it. Why don't you just weld it? Joel, what is the problem with when some mechanical engineer or somebody in QC or other interested party comes to you and says, well, it's metal, Joel, just weld it? Where do we even start with that statement?
There's a lot of issues with the just weld it statement. In some cases, it actually does apply depending on what you're doing. But if someone comes to you and you're out on a construction site or you're trying to put together something that's going to be a couple thousand feet below the ocean, there's likely going to be some governing standards that you need to adhere to. And you can't just weld it. You have to understand what you're doing, a lot of times why you're doing it, where is it going to go, what are the materials involved. There's a lot of questions that really need to be asked. And before you can go out and just weld it, you need to have a proper procedure qualified, selected, sometimes even approved by the client. So it's not, the just weld it case is very rare, and usually there are a lot more steps and intricacies involved before you can go out and actually strike an R.
The one just weld it that I'm not going to name, Joel and I worked for two different employers. We worked together for two different companies. We worked together at one company. He quit, went somewhere else, and then I quit and ended up at the same place. But anyways, at one of our stops together, we ran across and we're here in Houston area, right? So we ran across, somebody came to us with an oil tool, and I don't know anything about oil tools, but a lot of times they're made from 4140 or 4130. And these are just miserable materials to weld. And Joel and I ended up getting called out to a shop, and they're like, well, why don't you just weld it? Take a look at this weld procedure we're using and bless it, and we'll go on. And Joel and I just lost our minds. I don't know if you remember that specific case, Joel. They were welding the 4140 with no preheat, and they were using gas tungsten arc welding and the filler materials, and it was just a fiasco all around. I don't know what you'd like to add to that, but
I do remember that, and it was not something that I recommend ever, just doing. It's not a good situation to have to be in as a welding engineer and also as a company. Luckily, what they were doing was not terribly, dare I say, critical. So there was at least that, and we were able to find a solution that worked for everybody, which is, part of being a welding engineer. But ultimately, it could have been so much worse than it was had it not been so non-critical at the time. Because Garry, as you mentioned, that material is very, very finicky on how you weld it, what you weld to it, how much heat you put into it, how much preheat there is, post-heat, post-weld heat treatment, all those things. And that's again, the same, goes back to the intricacies of the just welded statement. If you don't know what you're welding on, and it's something that is highly critical and has a code attached to it and has customer requirements attached to it, just weld it never works. If you're in your shop putting together a trailer, there's a good chance that just weld it, you probably get away with it. But if you're trying to build a subsea oil tool that's going to be a couple thousand feet below the ground, it's not a good idea.
Well, and it gets back to, if you're just working with your garden variety carbon steels, the off-the-shelf tubing and whatnot, 99% of the time with that stuff, you're going to be able to make a weld with a low hydrogen electrode, or using ER70X6 to make a TIG weld, or make a gas metal arc or a MIG weld on that material. You're not going to get in trouble. We're talking about when you stray outside the boundaries of that little garden of carbon steel, the chemistry of carbon steels, the low carbon steels, and you start jacking up the carbon contents and the alloy contents like you'd get in a 4130 or a 4140 or any of those types of materials, where you have a much higher carbon content, and the material is going to require a preheat and or a post-weld heat treat. So this is where you get into it. Like, I remember that job though, our first question was, what is this stuff? We didn't know what the material was. So we started asking for, materials certs. What was this component made of? That's my first question anytime I dive into a weld repair situation. How about you, Joel?
The material type is one of the first questions, but usually my first question is who's the client? Who am I welding this for? In the industry that I'm in now, construction, or more specifically heavy construction for refineries, gas plants, things like that, it really becomes client specific what you're going to do, because each client has their own special recipe for making a weld procedure that's going to be successful. Even with your garden varieties carbon steels. And honestly, the next question would be what code? Because those two are going to dictate where you go as soon as you find out the material and the thicknesses. To Gary's point, garden varieties stainless carbon steel, you can weld with almost a coat hanger and you're going to be okay in most situations. But when you start adding in things like client requirements, and you start adding in things like your code you're going to be welding to, I can think of 4 off the top of my head right now that I utilize on a daily basis, and each one is just a touch different from the next. So you get those 2 down, then you get your material down. I mean, that's what you really need to know. That'll get you about 90% of the way there.
Well, and then once you figure that out, then you look at, we had the situation we were in, we looked at it, and I can't remember. I don't think they had a qualified weld procedure. Somebody in the office had just went out onto the net, the company intranet, and grabbed a weld procedure and ran with it. Well, we got a weld procedure. They didn't look at, is this weld procedure, this WPS, does it include the material we're welding on? Does it include the filler material we're using? And is our welder even qualified to use that process and in the position that we're talking about making this repair? So as you said, you got to get back to that. You got to look at the code, the customer, what are they going to buy off on, and the materials. There's a lot of variables that go into this. And then you might have a situation where, like Joel said, he's in heavy construction now. Well, the way a material, your garden variety carbon steel, performs outside in the weather here in Houston in December is not how it's going to perform in North Dakota in December and January, because you're going to have impact related issues, because that material is going to go through a ductile to brittle transition and it'll shatter like glass in that cold weathers. That's another thing you need. I try and dig up any documentation on the part on how it was previously welded also. How about what's your thoughts on documentation in regards to this repairs or NDE?
And documentation as far as how you document the repair that you've done, or documenting how you did the weld in the first place?
I guess start with the documentation on how the weld was done in the first place.
Usually what you really want to try and do is, for where we're at, we do what's called a weld map, which will list out your welding procedure, your qualified welding procedure. It'll usually have the client on it, and the welding procedure, once you know that, it'll tell you whether you had any special preheat requirements, any special post-weld heat treat or anything like that done, filler materials, base materials, things along those lines, and the weld map will give you an idea of what the material that y'all welded is and the thicknesses that you welded that material, or that material was supposed to be at the original time you welded it, right? So you get most of your information that way. And as far as inspections go, usually with the weld map, it'll have a special weld number specifically assigned to that, and that should correlate to other documentation within the QA/QC department that tells you, was this weld visually inspected? Did it pass? Which, if it's being left alone, it should have passed. And then also, was it part of any further inspections, your volumetric NDE, like RT, UT, something along those lines. And that gives you a real good picture of what was done to that weld to create it in the first place. Now, when you go and you need to repair a weld, and very interesting, I recently had a case where I had to do a repair on a post-weld heat-treated, impact-tested pressure vessel. And that falls under a whole different code. It was something, this is my first time doing. It's called a code called ASME Section 8 Division 1. And if you're listening to this podcast, I'm sure you're fairly familiar with it, or at least familiar with the name. But when you build a vessel, you build it to Section 8 Division 1. Then when you repair it, you have to go under something called NBIC, which is the National Board Inspection Code. Is that right, Garry, or is it insurance code?
I think it's inspection code.
I think so too. And then they give you a whole nother set of parameters that you need to adhere to just to be able to make a repair. They have situations or recipes, if you will, for if your vessel is just impact tested. Is it impact tested and post-weld heat treated? Is it impact tested, post-weld heat treated? Does it have hardness requirements on it? Is there none of that on there? And for each different situation, there is a different set of requirements that you must adhere to. And I had to qualify a procedure for one, like I said, that was impact tested and post-weld heat treated. So not only did I have to go back to find out exactly what was done to the vessel in the first place, find out all the MTRs, find out the material, even down to the chemistry of the material, to be able to be sure that I met all the requirements, and that the material I was using to qualify the weld procedure would fall within the range of what was used to make the vessel in the first place. Then I had to employ special techniques during the qualification process to be able to just make this repair. So all this to say is that when you are doing your initial weld, the more documentation that you can actually provide and create, it sounds odd, is better. As long as it's pertinent. You don't want just random stuff thrown in there. You want to make sure you have things like MTRs, material types, the preheat records and all that stuff as well. And then when you're doing a repair, the best way to approach it is to simply say there is no such thing as a standard repair. And just approach each one of them with a magnifying glass and look over it, make sure there's nothing that you're missing, because if there is, in this case, if the repair doesn't go well, then the vessel could lose its code stamp, and this is a very expensive vessel, and that's not something you want to do. Or in the event maybe you have a client who has a special repair procedure, codes, client standards, because if you do, and you've done your repair, and then all of a sudden it's not correct, you may end up paying twice, 3, 4 times as much to start over again in some cases because you didn't do the repair right.
A lot of guys have trouble, I think, when you're going they go from the field. Joel went to Ohio State University, the Ohio State University, I guess is how they like to say it on Monday Night Football.
The Z is very, very important. You got to make sure you have the Z in front of it. A lot of people be angry if you don't.
I went to a small school in Butte, Montana, a small engineering school, and I got a welding engineering degree there, Montana Tech. But you have a lot of people in quality control or welding-related positions, supervisory positions that were welders, and maybe they were a inspector or a QC function. But when you get up into start to doing repairs I want to say the deeper end of the pool, paperwork is the utmost. you want to keep your paperwork, you want to leave a trail of breadcrumbs for various reasons. I'd put together paperwork if I was doing something and leave it in a folder, so then if Joel needed to pick up where I left off or he had questions, there was some kind of trail of breadcrumbs where he could reasonably get to where I was at. Plus, if you're turning things into your client, if you're giving your client, the client's going to want paperwork. Okay, what did you do? Okay, here's my material certs on my filler material I used. This is our heat treat charts. Here's our impacts from our impact testing on our WPS, or it's all about paperwork. I can't stress enough on the paperwork side of things. And then you might have to redo this. Maybe there's another component that might have a similar repair. You don't want to have to reinvent everything in another month because you lost what you did on the last time. Thoughts on paperwork, Joel? I know you've never done any paperwork in your life.
The paperwork is one of those things that it's going to be the bane of your existence if it isn't already, because it's what they base everything off of. It's one of those things where, it picks if it didn't happen kind of saying, well, at this point, and the way it's been for years is, paperwork or it didn't happen. It does not matter if the weld is right there in front of them and they saw the welder weld it and they saw the welder get their electrodes and they watched them follow the procedure. If they didn't sign a document that says that they sat there and physically watched it, they can simply say, well, I didn't see it happening, even though they were there and they know you did it right. And they will just say, well, there's no paperwork, so we can't accept it. And now that's an extreme case, of course, but it has happened, and it is very difficult to recover from that without having to cut things out or scramble to try and prove that it in fact did actually happen. It's a lot of money and a lot of wasted effort and a lot of time that you just don't want to have to spend because you're busy doing other things, creating paperwork for other welds. So yeah, your paperwork, your organization for the paperwork is of the utmost importance. It is honestly is the most boring part of the job, but it is a big part of it. In fact, it's a big part of almost any engineering job is that paperwork. I spent some time as a mechanical engineer, and everything was all about the paperwork, detailing out your stress analysis to make sure that you had proof that, yes, I did do the stress analysis. Yes, here are the calculations. Yes, here's the FEA analysis of it that shows that what I did was correct. And then when you finally build the part and put it into testing, you have documentation of the testing. Yes, we did test this part. Here it is. This is what happened. It passed with flying colors, or no, it failed, and we went back and we changed these things. Paperwork is not to be shuffled off to the side. It's something to be understood, I guess, as probably the most important driving factor of everything that we do, unfortunately.
Well, and Joel and I spent some time, we're here in Houston, and we were working for a company right after, I don't say right after, but shortly after the Macondo Deepwater Horizon oil accident, BP, out there in the Gulf of Mexico. So a lot of the cowboy mentality that had gone on in the oil industry was coming under scrutiny because nobody wanted to be involved in $1 billion cleanup, or, you know what I mean? These things could be catastrophic for the health of companies. The paperwork became a lot more extreme, complex in that time frame. And I remember having people, they'd want us to, Joel or I, to do something. Well, they used to do it this way. Can't you just sign off on it? And Joel and I'd be like, nope. We'd play the Macondo card. You want to sign off on it, you sign your name to it. But if you're coming up here for the welding engineer to give the blessing and tell you this cowboy renegade thing you got going on is going to fly, it's not going to.
Yeah, it's unfortunate that actually it does happen. I think it happens with every discipline, though, honestly. Somebody will come and say, well, this is what I want to do, and I think it's the greatest idea ever, and I just need you to sign it and say it's okay. You could say that maybe it happens more often in welding engineering than other disciplines, but it's probably just because, tunnel vision, if you will. That's all Garry and I truly see most of the time. But if as a welding engineer, as an engineer in general, it's your responsibility to act ethically. And if what you are looking at does not give you any sense of comfort, I think is a good way to put it, with what you are signing your name on. Because remember, your name is legal. You sign your name on that, and you could be brought in and be deposed for that and be a part of a court case. So your name is all that you really have. And if you're not comfortable with it, or you need more time to investigate it, definitely don't sign off on it. Invoking something like Macondo, I think maybe, now that I'm a little more experienced, it is probably maybe not the best strategy, but it definitely gets the point across when someone gets really, really pushy, because sometimes that's all they really will understand is something massive like that, and be like, hey, look, dude, you know what happened with Macondo. We don't need to be part of that. We don't want to have an issue with that. And at the time, it was still fairly fresh in people's minds. Now it's several years past, and I almost guarantee you say Macondo to somebody, and they're going to look at you and go, what was that? So, yeah, it's very important to be able to be comfortable with a idea or a procedure that people are presenting to you. But it is of the utmost importance that you don't sign anything that you don't feel you can ethically support, because it could come back to you.
Well, and it gets back to having the paperwork. I've always kept a notebook. I go into a meeting, I keep a notebook, who I talked to, who welded it, what we're talking about, so if it ever comes back, I've got a trail of breadcrumbs to get me back to, oh no, we were in a meeting, this is what was going on. And I think a lot of the disconnect comes from, and this is my opinion, is you have mechanical engineers or structural engineers that are designing something, and they know those materials from a strength of materials and an impact and that frame of reference for that material, but they don't understand that they had one class in college on welding, or maybe 3 days where they talked about welding. So they start rooting around in these codes that they're designing things to, or trying to talk welding, and then they don't understand all the different things that can go wrong with welding. And I guess that's, to me, is when you start expressing it to people, well, it gets back to us saying, just weld it. Well, my uncle was a welder. He welded on farm equipment. Well, that's back in the carbon steel world, where you start welding on duplex stainless steels or nickel alloys or high strength low alloy steels, a number of different materials. There are just so many things that can go wrong that it just, I don't know. I'm trying to put it into words, but there's so many things that can go wrong that you're trying to stop from going wrong, that most people don't understand these things, that these boogeymen are out there. You're talking to them about, different weld defects that can happen if you don't preheat or post-weld heat treat, or go through all these precautions to get deposition of sound weld metal in a weld.
You come across that as well, and you also come across people who are very knowledgeable in it, that have some better knowledge of it. Maybe they were in fact a welder and they've worked their way up and they have knowledge of preheat and post-weld heat treat and stuff like that. But there's a difference between, and this is a delicate dance to dance here, is saying this, is that when you're an actual welding engineer, you are privy to information that a lot of times other folks, even though they are in the welding business, may not be. A lot of people that I come across will know the code, they'll know what to do, and they have a general idea of what's going on, but they won't know the specifics behind. Say, for example, when you're welding 1-inch or greater steel, plain carbon steel, per B31.3, as we B31.3, a piping code, you have to preheat to 200 degrees in order to avoid doing any post-weld heat treat. Now, a lot of people know that you need to do that, but they don't necessarily know why. And a lot of it has to do with hydrogen-induced cracking, stresses in the weld, things like that. And part of what we do is also educating. We need to educate, or I wouldn't say need, but we should share our knowledge and let them share in our knowledge of welding to help bring them up to speed on what they may or may not already know. And that's the other part that's hard to tread, is that a lot of these folks are very knowledgeable. They may already know, and you have to be able to dance the dance of, okay, well, you may already know this, but, I just want to let you know there's probably this, why, this, that, and be kind of careful that you're not stepping on any toes, if you will, out there. And it's hard to do, and it sometimes gets very frustrating. I mean, does that sound about right, Gary?
Yeah, I've had my battles, especially when I was a younger engineer. Yeah, trying to let somebody know, hey, we probably need to do this. Now that I'm older, heavier, got gray hair, most welders and foremen that I've dealt with, I generally don't have near the issues that I did when I was younger. But yeah, trying to communicate when I was in my 20s, trying to communicate with guys that were, my dad's age or whatever. All right, we got to do that. We need to follow the weld procedure because of this. I know the last procedure said we were doing something different and it was the same material, but we need to do this on this one because, and it's communicating and being respectful and, taking into account that that person has a wealth of knowledge and a body of knowledge, and maybe you just are giving them a little bit more to supplement what they already have. Yeah, it's a fine line to walk. And like I said, and this just gets back to just weld it, just that general theory of here, fix this, just go out there and weld it. And it's like, well, I need to know what I'm welding. I need to know what code I'm welding it to. I need to know where it's going. I need to know who the customer is. I used to have and I think Joel's probably got a copy of this too, but I had a kind of a homemade document that we would send people. Okay, before you even start, you need to answer these 10 questions for me. And I might get 6 answers back or 5 or 7, but you need to go do some research into what you want me to weld, and then we'll talk. But I'm not playing Scooby-Doo mystery and digging all this stuff up unless I absolutely have to.
Yeah, honestly, even if they can get you about 75% of the information that you need, usually the rest of it, you can kind of fudge the rest of it. They may not be able to get you the exact thickness that you need, but you can get into the wheelhouse of it. Or they may only know that it's a P1 material. As long as you can get into the wheelhouse, get them to get you into the wheelhouse, a lot of times you can kind of get a pretty good level of comfort of what you need to do.
When he throws out P1, I guess we're kind of operating under the assumption that some of these acronyms, but
That's
a
true.
P1 material in ASME Section 9 is your basic run-of-the-mill carbon steels. The kind of stuff you can weld with a coat hanger, more or less. It's in that ball game. It's just a run-of-the-mill carbon steel. Anyways, go on. I digress. I'll turn the floor back to you. Sorry.
No, that's pretty much so it. It's you do need to ask the questions. You do need to try and get as much knowledge about what you're doing as you possibly can. But there is going to be an aspect of, you're going to have to go and dig some of it up and find it. I've been in more than one situation where someone says, well, I need a welding procedure for, this. Okay. So what that sounds great. You're welding plain carbon to plain carbon. Okay. Well, what else? What temperatures are we at? Do we need, Sharpie impact testing? Are there special requirements? Things like that. And they'll say, well, I don't know. Here's the project number. Go look for it. And you got to go and dig it out. And that's not uncommon because they simply don't know. And they may not necessarily know where to find it. So it kind of does become up to you. Once they give you all the information that they have, it kind of does become up to you to try and figure out the rest of the information. And I will tell you right now, you're not always going to be right. You will be wrong sometimes. And that's okay, because a lot of times, even if you're wrong, you got to recover and get back on and do it again. It's just kind of how it goes. But people aren't always going to have all that information. And I remember plenty of times people would look at that form and go, well, I don't know the answers to this. And the next question would simply be, okay, well, if you don't know the answers to this, who can we go to together to get these answers? And that's when, after a while, you start to learn who the right people are to ask, and you'll end up with the information that you need one way or the other.
Yeah, you get into a company and you find that one person that knows where all the bodies are buried or has the information or can find you information.
Exactly.
But a lot of this just Weld It gets back to finding information that you're looking for so that you can start putting together a plan. And then you eventually get it welded up and get some procedures qualified, do the welding, qualify a welder. What else am I thinking? Figure out what NDE that you're going to need. And then you probably want to write you want to write a report on it. We did this. We repaired this part. The steps you went through. We welded this, this, this. Write a little book report on it, and then sign your name to it. Even if nobody ever looks at it, keep it on put it on your. Joel and I always go back and forth because I've got a flash drive, and I call it I don't know. It's the flash drive of evil, but it's my storehouse of everything. WPS's old report, PDF documents, whatever. Throw that document, your repair document that you wrote, you throw it on your flash drive of evil. Maybe you give a copy of your report to the client, get them calmed down, and go from there. Thoughts, Joel?
Yeah, the report's a good idea. Largely what will end up happening, at least in my world, is that you'll have all that documentation filled out prior to actually even making the weld, because by the time it's all said and done, all the reviews that I personally have to go through and all the information I have to send out to the client, to all my higher ups, to my boss, to his boss, to the project manager, so on and so forth, creates a pretty detailed picture of what we're going to do, how we're going to do it. And, you go out there and you see it and make sure they do it that way. Yeah, that's usually what ends up happening, is that you have that most of this way done in the beginning.
It's just getting all that documentation. And there's not one way to do it, but I guess we're having a philosophical conversation here on a direction to go and maybe some hints. Or maybe this is just podcast ends up being something you play to put your kids to sleep at night. I don't know. But I hope that we've kind of coherently covered, the direction you need to go when somebody comes to you and says, hey, I need this to be welded. And you start asking questions and they're like, well, just weld it. Yeah, and we're going to go forward. I don't know. I've got a couple other individuals that I'll probably bring on this podcast, and we'll talk about various subjects here and there, depending on availability and what needs to be talked about. We'll probably dive into some codes or maybe some specific materials. You've got my email address. If you lob me an email at gpacex@gmail.com and you want to, you have something that you'd like addressed, or maybe you have a question or you want us to rant on about something, do that. Any final words there, Joel, as we wrap this rant up?
I think mainly to summarize, a good professional response to the just weld it, or I need this welded now, I don't care how, or whatever thing, or this is not how we've done it before, we've always done it this way type of situation, is to, number one, be calm about it. That's one of the biggest issues is your reaction. And the number two, you got to be a bit of a detective. That's the second thing, is that you're not going to get all of your information directly from one person. It's going to be on you as a welding engineer, and it's going to be expected of you as a welding engineer to do some detective work, to do some digging, to find out the information that you need to make an educated decision. And I think the last and probably one of the most important things is that if you are ever forced into a situation where they want you to sign off on something that either A, was already done, or they're getting ready to do inside the next hour or so, and you're not comfortable with it, you don't feel you've had enough time to review it, you don't feel that it's being done right, or there's just something about it that seems off and you're not good with it. Remember, your name is all that you really have in the engineering business. So don't sign off on something that you don't feel that is something that you're not comfortable with, because you don't want to end up down the road being asked in front of God and country, why did you sign on this if things go bad? And that's kind of how I always look at it. Yeah, I think that's pretty much what I would add to that.
All right. Well, that pretty much closes this out. That pretty much concludes the Welding Codex and our episode called Just Weld It. Thank you, Joel, for participating. Look forward to talking to you soon.
All right. I look forward to hearing from you again, talking to you again.
Thanks for listening. Hope this podcast was worth listening to. We're going to have more content coming out. Also, if you want to shoot me an email, gpacex@gmail.com. Give me some ideas, or maybe there's some questions that you'd like me and Pete or me and Joel to answer in regards to welding codes, filler material, or any other material joining question that you might think we have a shot in hell of answering. Anyways, thanks for listening. Take care. Peace out. If you like these podcasts, stop by my website, texasweldingengineering.com, and go to the donation page. Use PayPal, throw me $1 or $2 so that the next time we hit the local Dairy Queen, we can get a large chocolate chip cookie dough blizzard. Also, if you're looking for CWI training at a reasonable price, check out train-eng.com. Also, if you're not familiar with my YouTube channel, there's a bunch of YouTube videos on there. If you just do a Google search under Garry Pace Welding ASME or AWS D1.1, there's a bunch of videos on there. Check those out too if you're interested.